Right, the topics we're going to do in these videos are simultaneous equations, surds, indices, and logarithmics functions, quadratic equations and inequalities, polynomials, and partial fractions. We can just do another questions. The concepts are pretty the same as the one that we've done previously for part I. The roots are real, so the values for discriminants will be more than or equal to 0. Okay, so we apply what we've learned earlier on. But before that, you would have to simplify this first. Okay, so some questions you will need to do some simplifications, group all your x squared term together, your x term together, and constant term together before you apply the concepts. Right, so remember that the values of a is the coefficients of x squared. The values of b is the coefficients of x. So some of you, if you're not careful, right, you may take your a as 3, your b as k minus x. Okay, which will be wrong, because the values of b is the coefficients of the x term. So you will realize that, how come there's an x there? So that will give you an idea that, okay, that's not correct. So I need to do some simplifications. I need to do some manipulations here, algebraic manipulations, all right, to get the values of a and b. C, it's any other constant, any other values without x squared or without x term. Right, so just plug into your b squared minus 4ac more than or equal to 0. Simplifying it, you will end up with a quadratic inequality again. So every time you have a quadratic inequality, what do? You draw your quadratic curve. Okay, this one is also one you will have to factorize it using your a squared minus b squared, which give you a plus b, a minus b. Okay, draw your quadratic curve. Right, we want it to be above your k-axis. Corresponding k values. Okay, this one is wrong. This should be k and not x. This is k. Right, this one is k. Okay, so part 2 is slightly more challenging. So hence deduce. Hence deduce means you make use of the answer from part I. Right, so let's solve the two equations. That equations 1 equals to equation 2. Let's see what happened. Simplify it. Alright, so you will observe that what you get here, right, it's something that is similar to what you have here. Okay, so if you do a comparison, alright, the values of k will be negative 3. Right. So if your values of k is negative 3, it satisfies this condition. Satisfy the conditions where k is less than negative 2/3. So hence there are two intersection points. Because from part 1, we are told that the roots are real. When the roots are real means you will have two solutions. Two solutions means two intersection points. And k equals to negative 3 satisfy your k less than negative 2/3. This is k, sorry. Right, so hence it satisfies one of the inequality, and hence it has two intersection points. Right, so in this case here, okay, this is slightly more challenging. Why slightly more challenging? Because you have to understand how this curve looks like. You want the curve to be entirely above the x-axis. This one means entirely above the x-axis. Or it's always positive. More than 0 means it's always positive. Right. So if you have a curve that is entirely above the x-axis, you can only draw it this way, a U-shaped curve. And it fits into the equations given because the coefficient of x squared is 2, which is a positive value. So hence, this is a U-shaped curve entirely above the x-axis. It means that there is no intersection point with the x-axis. Hence, there's no solution. So no solution means you have no real roots. It means b squared minus 4ac less than 0. Yeah, so all the explanations are there. Right, so this question is almost the same as what we have done earlier on, except that you're not given the coefficients of x squared. Right, you're not given the coefficients of x squared, but you know that it must be above the x-axis. All right, can you see that at first you are using less than 0? Then why is it that here it is more than 0? Yes, because you're multiplying every number here with a negative 1. So if you're dealing with quadratic inequality and if you're multiplying with negative on both sides, you have to flip the inequality sign. Therefore, the inequality sign changes from less than to more than. Right. You can divide by 4 throughout to get k squared minus 6k minus 16 more than 0. Factorize it. Okay. Anytime you deal with inequality, you have to draw your quadratic curve. Alright, you want it to be above 0. So these are the two that's above 0. The corresponding k values will be k less than negative 2 or k more than 8. Now, remember that this is a curve that's entirely above the x-axis. If your curve is entirely above the x-axis, it must be a U-shaped curve, right? If it's a U-shaped curve, then the coefficients of x squared must be positive, right? That's the reason why k less than negative 2 is rejected, right? You can only have this, okay, to be a U-shaped curve. This is for the first part. Not to confuse with this guy here. This one is for the first part here. So I'll draw it. I'll draw on top here. This is for this part here, which is a U-shaped curve. Right, so your k must be more than 0, must be a positive value to be a U-shaped curve, to be qualified as a U-shaped curve. Right, so this question will be easy peasy. Right, you don't have to use discriminant. Basically, you just solve the quadratic inequality. Right, factorize it, draw your quadratic curve. Okay, identify the regions that you're interested in. Find the corresponding x value. Corresponding range of x. Okay, so for this questions again is a repeat of the concepts we've learned earlier. A curve entirely above the x-axis, more than 0, above the x-axis, no real roots. Alright, so you should be able to explain now. We have done enough questions for you to be able to understand or explain why is it curve like that has no real roots. Alright, so you have to, this part here, because you're multiplying both sides with a negative 1, so your inequality sign flips. Okay, from less than become more than. Right, so very good. We have done questions on surds, questions on exponential equation, questions on logarithmic functions, questions on, my God, what did we do just now? Questions on surds, logarithmic functions, exponential equations. We just did it a while ago and I forgot. Oh, quadratic inequalities. So now let's deal with identities. So identities are basically just finding suitable values or substitute, okay, to find the unknowns. Okay, maybe you want to think about why is it a highlight x minus 1? What's the purpose of highlighting it? Yes, I highlight it to let you know that you can let it equals to 0. And what's the purpose of letting it equals to 0? Right, so from the solution, you'll realize that if I let x minus 1 equal to 0, I eliminate constant a, I eliminate constant b, and I can just find constant c. Right, so I did another highlight for you in pink. So you let it equals to 0, means you eliminate your a, and you can go and find b, because you already found c in part 1, the earlier portion. And if you found the values of c and b, you can just let x to be any other values, but don't use 1 and -5 because you already use it in the beginning to find the value for constant c and b. Alright, so these questions, if you look at these questions, what does it remind you of? Yes, you're given a cubic equations, and to solve cubic equations, which chapter do you touch base on? Yes, in the chapters of polynomials. So to do solving cubic equations, we have to use the calculator to find one factor, right? But before that, let's try to rewrite it. Put everything on the left-hand side. Alright, so step one, just use a calculator to find a factor. Alright, so depending on the brand of the calculator, I think if you're using Casio, it's mode 3 if I'm not wrong. So if I let x equals to 3, right, you get remainder equals to 0. So from there, x minus 3 is a factor. Alright, so once you get a factor, what's the next thing? You have to find the other quadratic factors, right? So that is where you use your long division. So step 1 is use a calculator to find a factor. So step 2 is use long division to find the remaining factors. Right, so 2x cubed minus 11x squared plus 3x plus 36 divided by x minus 3. Alright, so what we have will be x minus 3 multiplied with 2x squared minus 5x minus 12 equals to 0. This one you can factorize it further to be 2x. What was that? 6 and 2 can? 6, no, 4 and 3. 4 and 3. In terms of that, I already missed my calculator. Okay, so this will be plus. Yep. Alright, so x minus 3 equals to 0, or 2x plus 3 equals to 0, or x minus 4 equals to 0. From there, x is 3, one solution. X equals to negative 3 over 2, a second solution. X equals to 4, a third solution. So this is how you solve cubic equation. Alright, so now let's touch base with polynomial. Alright, so you're given two expressions there, two dividends. They have a common factor x plus 2. Find the values of a and b. Right, so here we have to use the factor theorem. Okay, so if a remainder is 0, that will give you just x cubed plus ax squared minus x plus 2 equals to your divisor, which is x plus 2 multiplied with the quotient remainder 0. So using factor theorem here, right, and you substitute x plus 2 equals to 0, which means you substitute x to be negative 2 to generate the first equation. And then for the other dividend, likewise, substitute x equals to negative 2, generate a second equations. Then just solve them simultaneously to get the values of a and b. So this question is pretty straightforward, just that you have to be careful with the algebraic manipulations because it's quite easy to make mistake. Alright, so for these questions, usually we will just let the dividend be called f of x. If you don't like this term f of x, you can let it be g of x or t of x or whatever. It's just a name only, right? So we're going to let x plus p equals to 0 because your x plus p is your divisor. Alright, it's not a factor because you have a remainder p. So just let your divisor equals to 0. So you substitute x equals to negative p. So you simplify the expression. Okay. Right. And recall that f of negative p will give you your remainder. So you let 2p squared plus 6p minus 3 equals to a remainder, which is given to be p here. You will get the quadratic equations where you can just factorize it. And from there, you can find your p to be half or negative 3. Right, so this question is just basically applying that a remainder theorem. Right, your remainder theorem f of x is equals to your divisor times quotient plus remainder, right? So if you let your divisor equals to 0, that means you sub x equals to negative a. Your f of negative a will be just your remainder. Okay, this is one way of finding remainder. Don't have to use long division. I think a lot of students like to use long division, and along the way they get lost because long divisions can be quite tricky if you don't do it correctly. It's very easy to make some mistakes, right? So this is a neater way to find remainder. So for part 1, the divisor is 2x plus 1, let it equals to 0. Means you substitute x to be negative half, so f of negative half will give you the remainder. Okay, this one you can just simply use a calculator. Please don't go and stress yourself doing use mentally during the exam for difficult numbers. Right, so in these questions here, it involve remainder, also involve factor theorem. So using remainder theorem, we can generate the first equation. And then using factor theorem, we can generate the second equation. Okay, where you can just solve them simultaneously. Right, we continue in the next. Alright, so here we are. We have two equations. Alright, first equation, second equations. Substitute equation 1 into 2, use substitution method. Alright, then from there, you can go on to find the values of P. And then substitute back into equations 1 again to find the values of Q. Okay, so our story does not end here. AMAP is really very long-winded. After finding the values of P and Q, substitute back into your dividend. What is a dividend? The dividend is the one with the many terms one. Okay, the one with a lot of terms that is a dividend. Substitute into your dividend. All right. And then what is the next thing we need to do? The next thing we need to do is to factorize it completely. So to factorize it, I'm only given this as a factor, right? So I need to go ahead to find the other factors. So what is the method that we use to find the other factors? Yes, long division. We use long division. Okay, so you go ahead and use long division. So finally, you have all your factors. Okay, and then this one is a quadratic expression. Can factorize it into 3x plus 5 and x minus 2. Okay, you're factorizing it. You're not solving it. Factorizing it means you leave your answer as bracket, bracket, bracket. Okay, as factors. All right, polynomials again. Okay, right. So this is something that's important. You need to recall this one. You've already forgotten this, then it's time to do some revisions. Recall that f of negative 3 will give you the remainder. Okay, so questions to ponder. Why do I let x plus 3 equals to 0? And why do I substitute x equals to negative 3? Okay, and then from there, you can find a remainder, which is 25 for part A. Likewise, also for part B, let the expressions be called gx. If you don't like to call it g bracket x, you can call it t bracket x, you can call it z bracket x. It's just a name only. Right, again, the questions to ponder is that why do I let x minus p equals to 0? Okay, and why do I substitute x equals to p to the above? Right? And from there, you will get a quadratic equations involving p, so p can be 4 and negative 2. All right, this is a rather interesting questions. You're given expressions, and then but they leave the same remainder. when it's divided by x plus 3 or x minus 2, and then it's supposed to prove that a equals to 14 plus b. Oh, given also the remainder is 9 when the expression is divided by x plus 1, find the values of c. Alright, so let's do the first part. Let us let the same remainder be r. If you don't like the letter r, you can call it, let it be letter capital A or capital B or whatever. Okay, don't use lowercase a, b, c because they've been used in the expression already. Or you can use x, y, z lah. Right. Okay, so remember your remainder theorem. Remainder theorem is dividend. Dividend, this guy is a dividend. Okay, this is a dividend. When you buy shares, to give you dividend, right? So this is equals to dividend equals to divisor. Divisor is x plus 3 times quotient plus remainder. That is a remainder because x plus 3 is not a factor. Right, so using remainder theorem. So we're going to substitute x equals to negative 3. Okay, this is a question for you to think. Why is it we substitute x equals to negative 3? Right, and then from there we can form the first equations. Okay, then the second equations is do the same. Right, form your remainder theorem. Again, I substitute x equals to 2. Okay, questions for you to ponder also. Why is it that I let x equals to 2? We have already solved enough questions for you to be able to answer both questions. Right, so we're going to let equations 1 equals to 2. Okay, and then you solve it. And then you realize that you can get rid of your c, because c, you have c on the left, c on the right, and c minus c equals to 0. The next thing is divide throughout by 5. Right, and then you get a equals to b plus 14 proof. Okay, I realized that you still need to do part C. Oh my goodness. So after finding the values, you need to generate another equations, right, to solve simultaneously with, is it to solve simultaneously? Don't know. Okay, let's do part C too. Let's do the last part together. Given also the remainder is 9 when the expression is divided by x plus 1. So how do we form it? Same thing, you use the remainder, what's that? The remainder theorem. So it means that 2x cubed plus ax squared plus bx plus c is equals to x plus 1 times quotient. The remainder is 9. So here I'm going to let x equals negative 1. Okay, again, go and ask yourself, why is it I let x to be negative 1? So I would have 2 bracket negative 1 to the power of 3 plus a negative 1 squared plus b negative 1 plus c equals to 9. Okay, let's try to simplify it. No space. I'm going to write it here. So negative 2 plus a minus b plus c equals to 9. Oh, so c is equals to 9 plus 2, that is 11. 9 plus 2 is 11. Minus a plus b. Oh, okay, interesting. Minus a plus b. So what is minus a plus b? Where do we find the values for minus a plus b? Yes, if you look it very carefully, you actually can get it from the first part. First part, we have a equals to b plus 14, right? So can you see that b plus 14 is equals to a? So minus a plus 14 will be give you minus a plus b, sorry, minus a plus 14 will, sorry, blah, 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 minus a plus b will give you negative 14. Okay, you just right from here to here. Okay, right, take minus a on both sides, so become minus a plus 14, then bring the 14 to over to the other side, so become negative a plus b equals to negative 14. So negative a plus b is negative 14. So this is where I'm going to sub it here. Right, the star, put the star asterisk here, and then the asterisk here. So therefore c is equals to 11 minus 14 gives you negative 3. Okay, that's how you find the values of c. Right, this is the questions on cubic factorization. Right, so to solve cubic factorization, we have to find one factors. So if you were to recall, we can actually use your calculator, I think mode 33, to help you to find one factor. Right, so the factors that I managed to find is x equals to 2. So what are the proper ways of showing it? You just substitute x equals to 2, and then, yes, and you get remainder equals to 0. So the remainder, this is your remainder, you'll get 0. So remainder 0 means x minus 2 is a factor. Using factor theorem, remainder 0 means x minus 2 is a factor. All right, so the next thing is that how do I find the other factors? Yes, using long division. So go ahead and use your long divisions, and then you'll get the remaining factors to be 4x squared plus 11x plus 6. All right, so you put them everything together, and then your 4x squared plus 11x plus 6 can be factorized further. This is a quadratic expression, can factorize further into 4x plus 3 and x plus 2. Okay, so you will get equals to 0 because you're supposed to solve it. When you need to solve something, means you need to find the values of x. All right, when you factorize something, you just leave it x factors into bracket, 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 bracket. That is factorized. Solving it means find the values of x. That is when you let it equals to 0. Something equals to 0, so x equals to blah, blah, blah. That is solving it. Okay, the second part is to do a comparison. You need to do a comparison, right? And then you can see very clearly that the values for x, the value that we found earlier on for x is actually also the values for e to the power of x. So e to the power x is equals to x. So when x is 2, e to the power x equals to 2, just bring ln. You don't bring lg, you bring ln because ln is log base e. So log base e is 1. Okay. Right. The other two answers will be rejected because ln of a negative number is not defined. So this question is, yeah. I think the solutions are quite short and sweet. All right. So for the first part, you're supposed to apply long division. If you've already forgotten how to do long division, then please refer to the earlier videos. Right, so after doing the long division, I think this question is to help you in the sense that a lot of you may not, I wouldn't say a lot of you, sorry, some of you may not check. Some of you may not check to see if the fractions given to you, is it improper or proper. So if it's improper, then you have to use long divisions to convert it into quotient plus remainder over divisor, right? So in this case here, this question is, there's some scaffolding for you, advising you to do long divisions, all right? And then express it as quotient. Your quotient is 3x minus 2. Your remainder is 2x plus 8 over your divisor, which is x squared minus 8x plus 12. So from there, then you realize that I need to apply partial fractions to your 2x plus 8 over x squared minus 8x plus 12. All right, there's no partial fractions for your quotient. Your quotient, it's 3x minus 2, nothing to be partial fractions about. Okay, so that it's part A. Oh no, we're not done with part A yet. So you need to factorize your denominator. Denominator, when you factorize it, will be x minus 6 times x minus 2. Two linear factors. So hence you can let it equals to a over x minus 6 plus b over x minus 2. Combine into one single fractions, convert it into identity. Right, do substitutions, appropriate substitution, find the values of b, then find the values of a, and put them together again. So the partial fractions, do not forget to include your quotient that you have found earlier. So it will be your quotient plus 5 over x minus 6 minus 3 over x minus 2. Right, so we're dealing with a linear denominator. So if it's linear denominator, it's a over x minus 1. This one here that we're dealing with is an irreducible quadratic factor. Right, so you will have to let the numerator be bx plus c. Okay, so the next step is just to combine them. Right, express it as an identity. Use substitution. So we let x minus 1 equals to 0. If you let this guy equals to 0, then you can just eliminate b and c first. Right, so you sub x equals to 1, and then you get the values for a to be 1/3. Right, sub x equals to 0 to eliminate b to find c. And finally, you can let x to be any other values beside 1 and 0. You can't be using 1 and 0 anymore because you already use it. So I let it equals to 2, and then from there, I go on to find the values of b. So finally, after getting all this thing, we can put back into your partial fraction. So it will be a, which is 1/3 over x minus 1 plus negative 1/3 x minus 1/3 over x squared plus 2. Okay, remember, do not leave answer as this because it is not. You have to simplify it. All right, so to simplify it, what you can do is just multiply 3 at the numerator, multiply 3 at the denominator. Likewise also for the second one, second fractions. So when you do that, let's see what happened. You will end up getting 1 at the numerator because 1/3 times 3 is 1. denominator becomes 3 bracket x minus 1. Okay, and then for the other fractions, you will end up getting negative x minus 1 over 3 bracket x squared plus 2. Again, this one is still not simplified because you can factorize the negative here to become minus x plus 1 over 3 bracket x squared plus 2. Okay, you have to do it until in this format, then it's considered simplified. Right, let's look at this question. So in this questions here, right, there's no scaffolding. That means that you are not advised to do the long divisions. So you have to check to see that this is an improper fraction. So how do you know it's an improper fraction? Let's look at the degree of your numerator, which is 2. Look at the degree of the denominator is 2. So if the degree is the same, it's an improper. Or if the degree of your numerator it's more than the denominator is also improper. So it's either the degree of the numerator is more or equal than the degree of the denominator, it will be improper. And if it's improper, then you should use long division. Okay, you need to use long division to convert them into quotient plus remainder over divisor. So we're going to divide it with x squared minus 2x minus 8. All right. So we can multiply with 2 and then just multiply with each terms again to get 2x squared minus 4x minus 16. Right. Negative 3x plus 4x gives you x. Negative 2 plus 16 will give you positive 14. Okay. Right. So in this case here, then that will be equals to 2, then plus your remainder is x plus 14 over your divisor, which is x squared minus 2x minus 8. Alright, so this is the one that I can partial fractions into. So can you see if you do a comparison? If you do a comparison, can you see that your values of a is actually 2? A is a value of 2. Right, so we're going to let x plus 14 over x squared minus 2x minus 8 equals to, use the letter that is given here, equals to b over x minus 4 plus c over x plus 2. Right, so convert them into, sorry, it's a bit messier. Convert them into a single fractions. Alright, then convert them into identities. Right, use appropriate substitution. We can let x equals to 4 to eliminate c, so we can find your values for b. Alright, then after that you can just let x to be 0. It's the most appropriate one to use. 0 is good because anything times 0 give you 0. So it is a nice value to use. 14 minus 6. 14 minus 6, that is 8, huh? Okay, so C is negative 2. Right, so therefore the partial fractions will be, okay, express it as A. A we found out to be 2 already. Then B we found out to be 3, so 3 over x minus 4. And then C we found out to be negative 2, so negative 2 over x plus 2. So that will be your answer for part A. Alright, brace up. This will be the last slide for the video. You can try to do B part 1 on your own. B part 1 is manageable. You just factorize the denominator, right? And then both of them are linear. So we can just let it equals to A over the first linear plus B over the second linear factor. And you should get this as the answer. Alright, I will do the part 2 with you. So for part 2, we need to factorize the denominator. So, okay, we do part 2. So that will gives you, factorize this guy. We have already done it in part 1. If you have already done it in part 1, you will factorize it to be x minus 1 and x plus 2. Right, and then with another x plus 2. Okay, so what do you see here? Yes, you have to pay attention to little details. What you see here is that, can you see I have a repeated linear factor here? Okay, I have a repeated linear factor, so I need to group them. I need to group your x plus 2 times x plus 2 into x plus 2 to the power of 2. Okay, so this is a repeated linear factor, all right? So if you cannot treat this as 3 linear factors, then your answer will be wrong. Okay, it's actually comprises of one linear and another repeated linear. So therefore, the partial fractions is a different story. Yeah? So for linear and repeated linear, the partial fractions will be let. First linear will be a over x minus 1. Second one will be b over x plus 2. Then c over bracket x plus 2 to the power of 2 squared. Can you see? Okay, it's a different story, right? All right, so the next step is to combine them into a fractions. Okay, right, and then again convert them into a identities. Okay, we're going to use appropriate substitutions. So what are the appropriate substitution? I'm going to let x minus 1 equals to 0. So let x equals to 1. So then I can eliminate my b, eliminate my c to find my a. So that will give me 9. So a will be 1 over 9. Okay, a is found. Next thing is I'm going to let x to be negative 2. Purpose is to eliminate my b and also a. So that will be left with c only. So c is negative 1/3. C is found. Very good. The last one, you can just let x equals to 0. A very useful number to use. 0 plus 2, 2 squared will be 4. Then substitute your a to be 1 over 9. All right. B, negative 1, 2. C is negative 1/3. Negative 1 equals to 1. All right. That will be negative 2b. This one, just use calculator to work this out. Don't need to crack your brain to go and think so hard. Okay, 1 over 9 times 4 plus 1/3. Negative 1/3 times negative 1 is just 1/3 lah. 7 over 9. So that is 1 minus 7 over 9. 1 minus 7 over 9 gives you 2 over 9. So b will be 2 over 9 divided by negative 2. Gives you negative 1 over 9. Okay, very good. So we have found all the values of a, b, c. Now we can put them into your partial fractions. Right. So therefore the partial fractions are all right. A I found it to be, where is my a? 1 over 9. So 1 over 9 over x minus 1. B, it's negative 1 over 9 over x plus 2. C is negative 1/3 over x plus 2 squared. Alright, remember what I said earlier on, you can't leave your answer as like that. So for the first fraction, you're just going to multiply by 9 at the numerator and the denominator. Second one multiply by 9, the third one multiply by 3. Alright, so what do I get? I would end up getting 1 over 9 bracket x minus 1 minus 1 over 9 bracket x plus 2 minus 1 over bracket 3, so on, blah, blah, blah. Okay, so this is rather tricky question, so I think it's good that I go through this video, all right? And that's the last slide of the whole video, right? So we have completed part A of the revisions, all right? Congratulate to both of us, okay, for achieving this great feat. There's so many questions that we've done, okay?